I wonder if we have a KSP lab.
Well, funny you should say that, Mr. Moore, because we do
Oh.
have a KSP lab. I know that's putting a smile on all our students' faces as well.
Mm-hmm.
Yeah. Yeah, this is, well, you can see up here, we're trying to use a titration to determine the silver ion concentration. But the way you have to think of this is, the silver ions are being created by this sparingly soluble salt, Ag2X. Right, so you have to realize that, you know, Mr. Moore and I took a bunch of this salt, Ag2X, dumped it into a beaker, stirred it like crazy, let it sit for a long time, developed the equilibrium, and then we poured off the solution to be titrated in this lab.
Mm-hmm.
Right, so you're actually titrating the silver ions that are in solution, but those silver ions came from this salt Ag2X. And there's a lot of possible identities for X. X is some -2 ion. It doesn't matter to you who X is. Right? That is not part of this at all. You're just ultimately trying to find the KSP value for this salt. Okay?
Mm-hmm.
So now, here is the titration reaction. Okay, we're going to put some thiocyanate into the burette. Okay, and of course, whatever's in the burette, you have to know the concentration of, and it is 0.0100 molarity. And so, the silver ion and the thiocyanate ion get together to make AgSCN, which is a white precipitate. So what you have to be able to do then is know where's the end point for this, right? When have I added just the right amount of when have I added just the right amount of thiocyanate to match the moles of silver?
Mm-hmm.
Okay, so we're going to use an indicator to help us with that. All right, now the thiocyanate makes a white precipitate. So if you go past the end point, the farther and farther past the end point you go, you know, you're seeing this white precipitate, but what you want to know is when do these moles equal each other? And so to use as an indicator, we're going to have iron +3 ions. Okay, now this is a different reaction. This is the indicator reaction. The iron +3, that is our indicator, when it reacts with SCN -1, it makes this ion that has a red color, kind of a brownish red color. So the whole idea is you start out with your saturated solution of Ag2X that has a silver ion in it. We'll measure that out. We'll put in 6 drops of the indicator, and we'll start to titrate, okay? And so the silver ion and the thiocyanate ion, they get together to make the AgSCN. That happens first. But as soon as all the silver's been used up and it's gone, then the iron that's there reacts with the thiocyanate to make this, and you start to get a red color. It's a little bit of a tricky endpoint because you'll see it's going to sort of look like a milky white color from the AgSCN. We're looking for when that first hint of red starts to show up. So it goes from being white to kind of a dingy red color. It's a little bit of a tricky endpoint. But as soon as we see this red showing up, that tells us to stop titrating.
So the silver and the iron will be in there together. The silver gets together with the thiocyanate preferentially before the iron will. So we'll use up all the silver and then the iron gets its chance to react.
Right, that's right. It's kind of like a battle for thiocyanate between silver and iron. Silver wins until it's gone.
Until it's gone.
And then the iron is left to react.
Okay, do you have that concentration of thiocyanate?
Yep.
And let's go run this titration.
Run some titration.
Last titration of the year, Mr. Hubble.
I believe it is.
Yep.
Normally I have Kleenex out because students are crying.
Yes, I know. Say goodbye to the burettes. It's a sad day.
Ready?
Here is our silver AG2X compound sample 2.
Yep.
And Mr. Hevel has measured out 10 milliliters, 10.0 in the graduated cylinder.
10.0 milliliters of the mystery salt AG2X. You know what's really funny, Mr. Moore, is I've had kids past years who they've been looking for X in the periodic table, trying to figure out who it is when there's no element with the symbol X. It's hilarious.
Yeah.
So you guys didn't see it yet? You haven't found it? Okay, now here's the indicator, iron +3. And through careful trial and error over many years, we figured out 6 drops is perfect. 1, 2, 3, 4, 5, 6. Got to get enough in there so you finally can see that color change. Okay, now, we did a fast and sloppy trial, and we know it should take ballpark roughly 8 milliliters.
I'm not focusing that very well, but it is on 0.
It would help if I put my...
Yeah, just students trust us that we're starting with
is.
the...
It is on 0.
This is SCN negative in the burette, and that's at 0.
Yep.
Okay, so yeah, our first...
It's about 8
trial.
milliliters.
Okay.
You know, so we'll run some in kind of quick, and you'll see it's going to look white as we begin because of that AgSCN precipitate that's forming. I don't know how well it shows up on camera.
Oh yeah,
but
we
it's
can see
kind
it
of
well. It's white.
Yep,
Yeah.
milky white. But when that silver's gone, we're going to start to get a little bit of red peeking in there.
Yeah, and you can tell we're getting close. It gets clumpy.
Yep, it looks different. Now I'm not, let's see where I'm at here. Yeah, I think it's...
Oh yeah, I'm seeing brown.
I think it's brown.
Oh, yeah.
It's hard to tell.
It is hard to tell.
You're looking for when is it not white anymore. and sometimes that's not easy. Okay, so this would be trial 1.
Okay.
If I put my hand behind it, if it helps.
Yep, I'm going to zoom in there. Okay. Got that volume. That's trial 1. Started at 0. Remember to read the burette to the hundredths place.
Okay, so let's do a redo. Okay, 10.0 milliliters, AG2X, trial 2, or sample 2, trial 2, 6 drops of indicator, 1, 2, 3, 4, 5, 6, and away we go.
So the ending volume from the last one is the beginning volume now.
Mm-hmm. I would have thought it would have been a little more added. I don't know, it's looking a little brown.
It's kind of brown, yeah. It's tough, you know, we've got to wait, precipitate, and we're looking for it to just start to turn brown. But
When you look straight down, looks very white. What do you think, Mr.
yeah, when we have a group of kids, students in the class, we'll have them compare it to one another. That helps too. And when we only have one,
Yep.
it is hard to tell.
Yeah, that looks brown, I think.
Yeah, I think it's not white anymore.
Yep.
Okay. And here is final volume. All right, we got it.